Hello, everyone. Welcome to the Creation Podcast Extra. I'm your host, Dr. Tim Clarey, Director of Research at ICR. Today we have a very special guest with us, Dr. John Whitmore from Cedarville University.
Hi, Tim. It's good to be here today.
It's great to have you here. Now, John, you got your PhD at Loma Linda University.
Yes, Loma Linda University in Southern California.
And your master's was from the Institute for Creation Research Graduate School.
Yes, when they were in Southern California as well.
That's great to have you here.
Yeah.
But today we're going to talk about something that you've researched for over 20 years, or pretty close to 20 years, the Coconino Sandstone.
Yeah, Tim, I've been studying the Coconino. I was first introduced to it probably 40 or more years ago, and started studying it in earnest when I was a student at Loma Linda. I was actually challenged by another student, and we went out to Grand Canyon one weekend to look at it together. We wanted to play devil's advocate with each other, and one of us took a flood model origin for the Coconino, and the other took a more conventional model, and we went out in the field as both geology students and just challenged one another as to what we saw. And that was probably my first time that I really looked at the Coconino with a lot of interest, and I just kept going from there.
Yeah, no, you and I were involved in ICR's FAST project, which stands for the flood activated sedimentation and tectonics. I was doing the tectonics, and you were doing the sedimentation for quite a while. That was almost 20 years ago on that. So.
Yeah, I think that project started in 2006 or 2007 when I was.
Yeah, I think I joined about a year into it or something like that. So. Yeah. But and both you and I were about the only ones that completed our projects. I think I worked on a fault up in near Cody, Wyoming, and you worked on the Coconino, and you've been working on it ever since with a lot of your students as well.
Yeah, that project was sponsored by ICR. Mm-hmm. ICR provided a lot of the funding for my project and for yours as well. Yeah.
Now, when I was in school as an undergraduate and even in grad school, if anybody talked about the Coconino Sandstone, they were talking about, the conventional story is that this was just a big arid sand dune area. There was no water involved. It was all just big sand dunes like the Sahara Desert today.
Right. The Coconino has been really used as a type example for what geologists are supposed to see with a desert deposit. And so typically what I was taught as a geology student and what others are taught is that when you see sandstones that have these angled layers in them, and when I say angled layers, it'd be layered an angle like that. When you see a sandstone with angles in it, big angles or long angles, you're supposed to think desert deposition. And so since 1934, when Edwin McKee, the very young Edwin McKee, published an article on the Coconino Sandstone, and he espoused the desert origin for that sandstone, geologists from then on out thought the Coconino was made in a desert. And surprisingly, what I found is nobody has looked at it really seriously until myself and some of my other colleagues came along and started to take a second look at it. So it's amazing that the sandstone is so famous, and yet so very few conventional geologists have actually looked at it. And, I was taught as a geologist, you got to go out and do field work, right? You got to get out and take a look at the rocks. And so that's exactly what we did. That's good. Because
I was taught in school, the best geologists see the most rocks. But unfortunately, not a lot of people do that. They just take what they're taught. And so unfortunately, geology students for decades, ever since McKee, they've been teaching that the Coconino was a dry, arid sand dune. Anytime they see big, what you were talking to, these beddings, these cross beds, we call them,
right?
That kind of cut across the bedding, but indicators of movement, indicators of flow, water flow, or wind flow. They always interpret as big sand dunes like the Navajo Sandstone or Zion National Park and places like that as well. And so it's just people just see them big, and they can't imagine water waves that big. So the conventional geologists just say, these must have been dry, arid sand dunes. And all the signs at all the national parks will talk about these big, dry, arid sand dunes.
That's right.
Even the research that I've been working on in the mega sequences shows the middle sequence, the Absarica mega sequence, or Absaroka. I'm not sure how you say it in Ohio, but the Absarica shows sea level dropping dramatically to kind of fit in these rocks that are so-called what they call Permian age sandstones that are found in many places around the world as supposedly a dry, arid time. But I'm finding even things contrary to that in fact the water levels were increasing at that time.
Yeah. So I teach geology at Cedarville University, and I have a lot of students, and I love to take them out in the field. So we come out west. We do a lot of things in the east as well. But I think it's really important to look at the rocks and look at the details of the rocks. And that's what I train my students to do. And oftentimes when we go on a field trip, I don't tell them a lot ahead of time because I want them to go make the observations. And what I found in the study of the Coconino is that people have, scientists and geologists have just read what the Coconino is supposed to look like, or more importantly, I've read that it's a desert deposit, and they have in their mind what desert sands look like, and they just assume that the Coconino is like that. And again, there hasn't been much published on the Coconino in a rigorous geological manner since 1934. And a lot of people have this idea that the Coconino is a desert deposit, so it must have rounded sand grains. It must have well-sorted sand grains. It must have crossbeds with certain angles and so forth.
Frosted grains in it.
Frosted grains and on and on and on. And you read all this stuff in the literature, this is what the Coconino looks like. But as I started to go out in the field and look at it, and that's not what the Coconino has. And Tim, we looked at the Coconino from north to south and from east to west. It's the name Coconino is just designated for a sandstone in Arizona. Mm-hmm. But as you go across state lines, the name changes. So you go from Arizona to the east into eastern Arizona and New Mexico. The name changes to the Deshay Sandstone, to the Glorieta Sandstone. You go up into Colorado, and we've seen that together at Garden of the Gods. It becomes the Lions Sandstone up there, and it continues all the way up to the Dakotas. And so we've actually traced the Coconino out from California all the way up to the Dakotas. A little bit of it, I think, comes over here into Texas and Oklahoma. And it's just an amazing deposit, very large.
Yeah, I think your research also showed that the Ten Sleep Sandstone in Wyoming was
That's
part
right.
of it. When I worked for the oil company, we studied the Ten Sleep. Ten Sleep was one of the big oil-producing reservoirs in the Bighorn Basin of Wyoming. And we were always taught, same story, conventional story. These are big, dry, arid sand dunes that somehow formed, and we're chasing these big, dry, arid sand dunes around, and everybody just accepts it like it's a fact.
One of my students was in field camp in Wyoming, and they went and saw an outcrop of the Ten Sleep Sandstone, and the professor said, "Well, what do you see in the Ten Sleep?" "Oh, big crossbeds," and they wanted my student to say, "Well, it must be a desert deposit," and that's what the class was talking about. My student raised his hand and said, "Well, doesn't the Ten Sleep have a lot of dolomite in it?" And dolomite, of course, is a marine mineral, and the Ten Sleep is just full of dolomite. And that kind of stumped the professor.
Dolomite is, I mean, everybody understands that's a marine deposit, just
that's
like, most limestones are marine deposits. Maybe you get some freshwater ones, but dolomite, I don't think they've ever found in a freshwater. It's so hard to find even any dolomite forming today.
That's right.
That's another whole program we could do on dolomite. The dolomite problem, they call it. There's a lot of things in the flood rocks that we're seeing that we really don't see much today, and dolomite's one of them. A lot of dolomite early in the flood for some reason, but the presence of dolomite is very, very powerful. And that's one of the things I know you found early in your studies. When you started looking at the rock, you started cutting those rocks into thin sections.
That's right.
And looking under a microscope and seeing, what are we seeing here? And one of the things you found was something called a dolomite ooid. Mm-hmm. Could you explain a little bit about what a dolomite ooid is for the audience?
Let me talk about thin sections too. So in our studies, we thought it was important to widely sample the Coconino, so over its entire aerial extent. But when we had the opportunity, we also wanted to sample the thickness of the Coconino to see how it changed from bottom to top and so on. And we collected samples in a lot of those areas. In Grand Canyon, we actually got permits to collect some of those samples. But you collect a sample about this size, and you can cut it and then glue it onto a microscope slide and polish it down so you can see what it looks like under the microscope. And the microscope studies on this rock were probably the most important thing that we did. Nobody before us had really published a lot of microscope thin section slides of the Coconino to see what it looked like microscopically. They always assumed that it looked a certain way microscopically, but they'd never documented it. And so we actually cut 400 thin sections of Coconino. That's a lot of work. Ray Strom up in Canada did a lot of work
thanks
on
to Ray,
that.
I did, for my dissertation, I did about 50, and that was a lot of work. 400 is,
But the study of those thin sections was so important. And one of the things that we found at actually quite a few locations were dolomite ooids. Ooids are kind of unusual in their own right, but most of the time ooids are made of the mineral calcite. And I don't know that I've ever run across dolomite ooids anywhere else.
I never have, because the ones forming today are always limestone. There's tiny little balls of carbonate rock that kind of roll around.
They kind of form like a snowball rolling down a hill. So in the surf, they typically, today, they form along beaches and so forth as the surf rolls back and forth, and they accumulate the calcite around them. And under the microscope, they look like a little BB, and they have concentric rings and so forth. And we actually found dolomite ooids in the Coconino.
Yeah, and how would you explain that in a desert? How would you get those in a desert? Like middle of the Sahara Desert, and you have dolomite ooids.
Nobody has explained them to me yet. I had an interesting experience at a GSA conference one year. You go to GSA oftentimes. And I had a poster on the Coconino, and I had dolomite ooids up there, and I had a geologist come by, and I mean, we're trained to recognize what ooids look like, right?
Yep.
And this geologist refused to recognize that they were ooids just because they were in the Coconino.
Yeah, I mean, to me, it's a deal breaker. I tell people there's dolomite ooids, and if you're a geologist, you know right away that that's got to be a marine deposit.
Yeah. But some people have told us, well, maybe there is a little bit of dolomite in the Coconino, but a little bit of dolomite doesn't make it marine. But actually, we found dolomite in a lot of our locations. And I've published maps of where the dolomite occurs in different locations where we've had it. We found dolomite beds, actual beds of dolomite. We found the dolomite ooids. There's dolomite cements, dolomite rhombs, dolomite clasts that are actually bigger than the sand grains themselves. So it's not like we found just one type of dolomite. We found multiple types of dolomite in multiple locations within the Coconino.
Yeah, it's if it was limestone, you could argue, okay, these are just little lakes maybe that formed in between the dunes. But dolomite's a little tougher to explain away like that. So
now there is limestone in the dolomite too. We found carbonate cements and stuff like that, which is not too unusual in a sandstone, but dolomite is a deal breaker, like you said.
That's what I said. I think that to me, that's the really strongest evidence. I think the most compelling evidence we have that this is marine and not deposited by dry arid sand dunes is those dolomite ooids and the beds, as you mentioned as well.
That's right.
Very, very important. People need to know this because nobody knew.
Yeah.
Nobody did the work that you did.
Right.
Nobody was spending the time looking at thin sections. And we see the same thing in a lot of studies. I know Andrew Snelling did some articles on the Cambrian rocks in Grand Canyon recently, and he was one of the first people to look at thin sections of those as well in decades.
You would think that that thing people would be all over that, but they're not.
Yeah, they just
takes a lot of time to cut thin sections and study them, and so I think geologists have gotten away from that, but it's such an important piece in interpreting a rock and how it formed and where it came from.
Yeah, I think they're happy with the story. They made a good story up, and the conventional story that this is a dry arid sand dune, and they put it in geologists' heads every time you get, as an undergrad and a grad student, you see big cross beds, these big, huge, indicators of big water waves, which we would interpret as flood geologists, and they interpret it as dry arid sand dunes. Anytime they're big, they immediately jump to these are dry arid sand dunes.
Right.
Oh, you've also worked a lot, I know, on the angles of these, and there's a lot of misconceptions even in the creation community, myself included at times. I got confused about the angles because I heard different things, and you tried to set the record straight a couple of years ago at the International Conference on Creationism.
Yep.
And I think you set the record straight quite well. And so can you explain the number that you need and then how you really differentiate between water, sand dunes, and wind-blown sand dunes?
So the Coconino is unusual. Most sedimentary rocks that we look at have horizontal layers in them. And the Coconino does have some horizontal layers, but in between those horizontal layers and beds and bounding surfaces, there's angled layers in the Coconino, and those are called cross beds. And a lot of people have made a lot on these cross beds. And, before we went out into the field and stuff, I had done a lot of reading and so forth. And I read all over the place that the cross beds are steep. And people had published in books that the cross beds are steep. And, steep cross beds at the angle of repose are usually around 32, 33, 34 degrees.
For dry sand.
Yeah. And even in wet sand, it turns out the angle of repose underwater is about the same.
Oh.
Doesn't matter. But they kept saying everywhere that the cross beds were very steep. And so I went out and started measuring things. And to measure cross beds properly, you have to measure it with this tool called the Brunton compass. All the cross beds I measured with this. You can actually do it now with a cell phone, because the cell phone has an angle measuring device in it, and you can get an app. But you can see in this Brunton compass, there's a little clinometer in here, and I can adjust the dial on the back, and you can rotate this thing and very accurately measure the angle. And you have to actually do this on a flat surface. You can't use a protractor and measure it by off a photograph. I've seen people publish photographs of the Coconino with a little angle on there, and they say, "Oh, this angle is 32 degrees." But if you're looking at the bed from up high or that way, or from an angle, if you're not looking straight down the cross bed, your angle is either going to be too high or too low.
Right. You got what they call an apparent dip in geology.
You get an apparent dip.
You're going to get something that's always less than the real dip, unless you're perpendicular to the actual true dip surface. You got to be measuring perpendicular to the actual strike of the beds.
And so I was taught as a freshman geology major, and I'm sure you were too, on how to measure strikes and dips, right?
Yep.
And you have to have, put your compass directly on the crossbed dip. And I usually run water down the surface because that gives you the maximum dip, and that's where I'll take my dip measurement, and I'll make a strike measurement as well.
I used to turn my compass a little bit to get the maximum angle.
There you go.
The maximum angle is the correct angle.
Yep.
So you can
Sometimes it's hard when you have really low dipping beds and so forth, but I always used a little bit of water, and that way I knew that water is going to run downhill. But as I started measuring the crossbed dips, I found that the average crossbed angle was around 20 degrees. And most of my crossbed dips were rated in around between 17 to 24 degrees in the bulk. I did get just a few that were a little bit more, and just a few that were a little bit less. But all my measurements were tightly in that range, between about 17 to 24 degrees. And I did the statistics on it and so forth. Other people besides me have done dips. I had a student that did a dissertation on the Coconino, and she got the same results, measured different crossbeds, different areas in the Coconino that I worked on, exactly the same results. I came across a paper by Reiche in 1938. He had a whole set of measurements published, not only from the Coconino, but from the Navajo, the Cedar Mesa, and some other cross-bedded sandstones.
Which they all claim are dry, arid sand dunes.
Same dips and same average. As I started looking at it, I'm like, well, that's really interesting, And, some people might claim that I was biased when I went out and measured crossbed dips, and I only measured the ones where it's shallow or, something else. But my measurements completely match what others have gotten.
Well, like you mentioned, in 1938, they were finding the same thing. So,
and
but that's a lot different. It's a lot different than the angle of repose and the low 30s.
Right. And so some people might claim, well, it's compaction that squeezes them and makes them lower. But if you compact a sandstone, that might change the dip angle by a few degrees. And we've looked at that and have kind of ruled that out. But here's the interesting thing, Tim. If you look at modern sand dunes, modern sand dunes do have very steep crossbeds up to about, a lot of them are around 33 degrees. They can even have some that are up to 40 degrees somehow. But they also have a lot of crossbed dips that are really low in angle. And there aren't as many measurements out there in the literature as there are for sandstones, but there are some measurements out there for sand dunes. And so I looked at that data as well. I was able to find hundreds of measurements. And with the hundreds of measurements I have from the Coconino and hundreds of measurements from modern crossbeds, I could compare the two sets of data. And statistically, they are very different. The range of the crossbeds for modern sand dunes is really wide.
So the arid ones are very wide.
Yeah, if I talk about a bell-shaped curve, the bell-shaped curve of the Coconino is very tight, with most of the data falling between about 17 to 24 degrees. And then with modern dunes, the range is much, much wider.
You go from 40, you were saying, as high as 40.
Up to 40,
all the way down to like 15 or in the low teens and that sort of thing.
So one thing I want to mention, Tim, is, we're having a discussion here, and I would really encourage the viewers to go read the literature. A lot of people oftentimes will, critique a podcast or something like this, and I try to be scientifically accurate, but, a lot of times I'll say something to maybe explain it in a more simple way so people will try to understand. But it's so important to go out and read the literature. And so I've published this and all the other things I've been talking about. I've published. Yeah,
I've got a list of a bunch of publications. Right, just a smattering of them right here. You can kind of see some of your articles. A lot of these are in Interest Research Journal or in the ICC, the Proceedings of the International Conference on Creationism.
And we've published some stuff in the secular literature too. I've been at Geological Society of America for years, publishing short abstracts on a lot of this. We published an article in Sedimentary. We've published some articles in the secular literature.
I know you've had problems getting some of those in because the stigma is so strong out there that these are. A lot of reviewers just like, no, this can't be.
Yeah, it's been difficult, but we've managed to get some in here and there.
I remember seeing a couple of them early on. It was pretty impressive to get those in there. But it's good work. It's really, really good work. No one's doing this.
Right.
And so this is some of the best, I think, creation flood geology research that's ever been done.
Yeah.
And so I credit you and your students and your team and, Ray Strom and Stephen Chang and others that helped up in Calgary as well, do the thin sections and the analysis, et cetera. It's all kind of a team. You have to work as a team to get all this done.
So one of the interesting things we found when we started looking at these thin sections, we had all these expectations about what it would look like. And so if you actually go and look at desert sand, and I've looked at a lot of desert sand as well as the Coconino, but one of the things you see when you look at desert sand is that most of the grains are round, kind of ball-shaped or sphere-shaped, and most of the sand is all about the same size. And when we started looking at the Coconino, we found something very different. We found many of the grains had angles on them. It's subangular to subrounded is the category of the Coconino. And we also found that the sand was moderately sorted to poorly sorted in a lot of ways. And I know those terms may not make a lot of sense to our audience. You as a geologist know what that means. But in other words, we found something very different under the microscope than what was published.
You found almost two sizes. The peaks were, if I remember right, reading your papers, you found two different sizes that were sort of what we call bimodal.
Bimodal, like a two-humped camel, right?
As opposed to a single one, which is what you find in the dry arid dunes. So again, all these things are telling us that these things were deposited by water. Yeah. And yet the conventional community just kind of flat out ignores it all.
Yep.
They criticize what you've done, but they don't go out there and do the work to show where you're wrong.
So another thing that we found looking at this under the microscope is that there is a significant amount of mica, specifically a type of mica called muscovite. And mica is a very soft mineral. So minerals have different hardnesses, and the hardness of your fingernail is about 2.5. Mica is about that hard. And if you put mica in a desert setting, it disappears fairly quickly. And literature supports that. We've run across a number of studies where geologists have traced various minerals up the South African coast in the Atlantic Ocean. And then that sand gets picked up by the beach after getting transported hundreds of kilometers, thousands of kilometers, and not really changing at all. It gets picked up and transported into the desert. And the mica disappears, the Cape feldspar disappears. And we suspected this for a long time based on some of our experiments. But, this sandstone has mica in it. And of all those 400 thin sections we looked at, almost every one has muscovite in it. And we wanted to do an experiment to demonstrate this.
You put your students to work. Right? I remember reading about this. This was really fascinating.
We actually got that published in Aeolian Research, a secular journal that studies sand dunes. But I gave a student some sand, quartz sand, that had some muscovite in it. And I said, here's a pickle jar. And the student put an airplane propeller in the lid of the pickle jar and made this thing go around, not very fast, just fast enough to make the sand move around the bottom.
Stirring it, basically.
And I said, now you need to watch, and you need to find out how long that mica, lasts in there. And what happens is those sharp, angular quartz grains chew the mica up and turn it into dust. And he checked it 2 weeks later. Dr. Whitmore, I can't find anything. I said,
it's gone. Wow.
You need to be a good scientist. I want to know how long it lasts, not that it's gone after 2 weeks. And so he redid the experiment, and it lasts less than 48 hours. Wow. It gets chewed up. So that's an error. And so I had another student do a similar experiment a year later, took the same pickle jar, filled it with water, and turned it sideways and put it on a rock tumbler. And so this thing was, tumbling around with water in it. You could actually see the mica flakes, moving around in there because they're shiny and silver colored. And this thing ran 24/7, sitting right outside my office. And finally, after a year, I couldn't see any visible change that had happened in that jar. And I said, turn that thing off.
The mica flakes were still there after a year.
Yeah. And
just because there was water in there.
The water is cushioning the interaction between that soft mica and the hard quartz. And so it's preserving them. And so we published that research in a secular journal. And, we think that that's a really good indicator that means that this sandstone was made underwater somehow. We're not exactly sure how the Coconino was laid down. It can't be made, by grain, falling through a water column. That would take too long. But it does mean the presence of mica there does mean that it was made in some type of watery setting.
Right, or they'd be destroyed. And you saw it was, as they say, ubiquitous. It's in
That's
all
right.
Those,
it's
in
all over
those,
the place.
Just love to say that word.
And we found this, in the northern part, and the southern part, the eastern part, western part, and vertically all through it's everywhere. And a lot of these other sandstones that are very similar to Coconino, and we can trace out, those had muscovite in them too.
Wow.
So
even like the 10-slate sandstone in those places. Wow.
Yep.
And you said one other thing that we didn't really touch on was that when you looked at the extent of this, it goes all the way from Wyoming all the way down to Arizona and beyond. But you saw also a lot of the cross beds, or the angle of flow was very consistent. Is that what you're finding?
All these dip angles, this would be a dip angle like this, they would all point south or southwest.
Maybe
most of the time.
Explain a little bit how the cross beds form,
what you have, and this can happen in air or underwater, is that sand grains get carried up this way and then fall down this way, and this angle right here indicates a direction of transport most of the time. There are few examples where you have really weird dunes where it might actually be backwards, but
and you can generally see this even in shallow water. You see ripples, but if you kind of cut a cross section into those ripples, you'd see these crossbed.
If you're
standing the ripples migrate, they actually drop off the front end, they bounce up the backside, and they drop off the steeper lee side, and that's what makes these preserved crossbeds.
Yeah, if you're standing like next to the edge of a river, I've seen this happen lots of times, and there's ripples in the sand down there. you can actually see the process. Now, I'm not sure exactly that's how the Coconino crossbeds were formed, but that's the general idea. I've been thinking about the past months about the crossbeds in the Coconino, and one of the things that I realized is, the nautiloid bed, the Whitmore nautiloid bed in Grand Canyon, that is, basically unbedded in the Grand Canyon. But as you go west, and this has been documented by Steve Austin and Derry Stansbury, as you go west, that bed explodes into a really thick cross-bedded section.
Of limestone.
Of limestone, yeah, cross-bedded limestone. It's the particles it still has particles in it. But I'm thinking about a similar process for the Coconino. Is that possibly another explanation for how those crossbeds form? Because I don't think it's a conventional explanation for the formation of those crossbeds.
Could be, yeah, because it is such a large deposit. I mean, how do you deposit and show a consistent, directional flow?
Yeah.
Across, pretty much the whole American West. I mean,
so that's just a brainstorm that I've had. I still need to test that out and tease that out scientifically and talk to my colleagues about it. But that's the process of science, right? We come up with a really weird or wild idea, and we talk back and forth between our colleagues and try to come up with an explanation for what we see.
So you're like me, you lay awake at night thinking about these things in the bed.
I do.
In the middle of the night, sometimes I have to run up and write a note down in the middle of the night and go back to bed, and my wife's like, what are you doing?
That happens.
I'm like, well,
often,
I just thought of something in the middle of the night. And I solve the world's problems in the middle of the night.
Sometimes
I got to write it down.
Sometimes an idea comes to you, yeah.
Yeah, see, that's interesting.
Yeah.
See, we're a lot more alike, not just in our geology degrees, but also in our the way we think, I think.
That's
we've been trained maybe that way. Or else people that think like us are attracted to geology. But to me, geology has been fascinating because you're looking at historical events that took place, and you're trying to figure out what's the best explanation to what made that bed, or how did those things get buried, how those fossils get there. It's almost like studying history, but we're only looking at the rocks as our pages, and it's fascinating. Even every layer tells us a little bit about it. But they all seem to go back to the flood. Most of the sedimentary rocks we see all over the world, all these massive deposits, all to us are best explained as flood deposits during the flood year.
Yeah.
They're not just, random deposits over millions and millions of years, as conventional scientists would say. Mm-hmm. But unfortunately, that's what's being taught in all the schools, except at Cedarville and a few other schools around here. So tell us a little bit about the geology department at Cedarville, maybe, if you get a chance.
We've had a geology program at Cedarville since 2009. That's when the first geology students started, actually, as sophomores. They had already taken their freshman year of geology. Our first graduates were 2012. Okay. We've probably had 65, maybe even 70. I've lost count graduates since then. Okay. But we have about 25 majors in the program at any one particular time. And the philosophy I take when I train my students, I want them to know a conventional view, and I want them to know a biblical view of geology. I want them to know both. And the reason is, one of the reasons is it teaches them to be better critical thinkers. It teaches them, how can I explain this, or how can I look at things in multiple different ways. And so I want them to understand that. But the other thing is that, when I have a geology graduate, I want them to be able to go out into the world, and I want them to be able to interact with people that believe differently than they do. Mm-hmm. And what good is it if we don't, interact with others that believe differently? We're called to be salt and light, right? Mm-hmm. And so I train my geology students to think both ways, and encourage them to, go out into the world and get a job in a secular setting. And we've had good success. We've put our geology majors in lots of different places. A number of our graduates have gone on to get PhDs from secular schools. So we think we're doing the right thing.
Mm-hmm. No, I think you got a vibrant program going there. So it's impressive, and a lot of it's because you kind of were the start of it all. You want to get it going. Yeah. I was on the original board to help you kind of get things. Yeah. Make sure you had the right kind of coursework lined up, and there was the whole group of people. It wasn't, but it was really your kind of plan to get this going. You could have a young Earth geology department
Well,
which is the first one in the country. Since
I always tell my students, it's not my program, it's God's program. If He wants to pull the plug on it at any time, He can.
But He gave you that desire to put that together.
He did.
The Lord Jesus is using, I think, Cedarville to produce a lot of people to think differently than the conventional geologists. And the way you guys are teaching them, I think you're showing them that geology can be interpreted a completely different way, and still hold to the science of geology. That's the beauty of it all. So, well, let's go back a little bit to the Coconino. There's a couple of things I wanted to address yet. There was something called the recumbent folds.
Oh, yeah.
You did a whole paper on recumbent folds, you and several other co-authors. And what's a recumbent fold, first of all?
I remember sitting on my computer one day, and a friend of mine out in Sedona, Arizona, sends me a picture, and I open this picture up, and my jaw about hit the desk. And I saw these folds in the Coconino that look like this. They're kind of U-shaped, laying on its side. And as you, as structural geologists, know, when you have a fold that lays on its side like that, we call it a recumbent fold. But there's something special that can happen when you have cross-bedded sandstones and a strong current, or maybe some other process that happens while the crossbeds are being formed, can actually flip the rock over into this U-shaped bend, and we call that a parabolic recumbent fold. It's called parabolic because if you remember back to your geometry days, that's a parabola, right? So this is a parabolic recumbent fold. And I didn't know about these things. I didn't learn about them as an undergrad. Even at my studies in ICR, Steve Austin, I ribbed him the other day.
He didn't teach you about those?
Steve, how come you didn't teach us about parabolic recumbent folds? But I saw these things in the Coconino, and I had to go see what they were and figure out what was going on. So you didn't
see these when you did your initial studies?
No, these are
mostly in Sedona?
Some unusual things around Sedona. We have found one other location up in Wupatki National Monument where they are. There's another location in Oak Creek Canyon where Guy Forsyth has found them. But we didn't know what they were at the time, and I did a little bit of research. And the important thing about these things is they can't be slumped sand dunes, or they can't form from groundwater flow. They're very regular. And this very regular sideways U pattern, you can trace it along the outcrop. One outcrop where the folds are really thick, and I got to convert from meters.
Oh, yeah.
But forgive me if I talk in meters here, but a meter is about a yard, right?
Yeah.
But the big fold we had was about 7 meters thick, so in excess of 20 feet. And we traced it, along the outcrop for 50 meters. Yeah, for 50 meters within a cross-bedded unit on both sides of the cliff for half a football field.
Wow.
There's another location where the folds aren't as thick, but we could trace them for 450 meters. So what is that, about 500 yards or so, 1,500 feet?
About 5 football fields.
Yeah.
Wow.
And so these things they're only known to form in underwater settings with very strong currents. And if you want to see the details on those, I've written a publication on that.
Yeah.
But I remember being at the geology meeting one year, secular geology meeting, and had these folds up on my poster. And a guy came up and said, "Oh, parabolic recumbent folds, those are so cool." Mm-hmm. And, we were talking a bit, and then he looked at the title on my poster and saw Coconino Sandstone. Oh, wait a minute. Those can't be parabolic recumbent folds. That's in a Coconino. So it just shows how worldview can affect your interpretation. It's the same
with the Dolomite Ulids you talked about earlier.
Yeah,
as soon as they realize, this is Coconino, it can't be. These can't be.
Yeah.
But yet they are.
Yeah.
They're right there in front of them. They recognize really what they are right off the bat. And then it can't be, because they're a worldview, like you say. It's amazing.
Right.
What science, what bad science is actually the conclusions that are drawn when you have your mind made up that this is a dry area sand dune, just because they had big crossbeds or these types of features like this. Obviously, those can't form in the Coconino, so those can't be. It's amazing, the denial out there of the real science, what they see right before your eyes, observational science. And in your case, with the studies with the muscovite, it's empirical science. You're actually doing the experiments. You could repeat it over and over to show that muscovite can't survive in dry climates. It can only survive if it's in water. Yeah, I studied groundwater flow a lot for my dissertation myself. And groundwater flow is laminar. It means it doesn't have the turbulence. It moves very slowly. So to say groundwater could do that is everybody that says groundwater flow.
I'm still trying to wrap my head around
it's like,
that.
how would you do that when you have layers already laid down and then you try to curl one layer?
Or the collapsed dune hypothesis. It should penetrate through multiple layers of crossbeds. It shouldn't be confined just to one set of crossbeds. But when you have to fit it into your worldview, you'll say some kind of really out there things that really aren't very scientific at all, unfortunately. So there's a lot of cool things in the Coconino. We don't have time to talk about everything today, but a lot of people have probably heard about the footprints in the Coconino. And there's just these amazing trackways in the Coconino.
By the lizards and things.
Yeah, Leonard Brand from Linda University has been studying those probably 50 years now. And he, in my view, is the world's authority on the Coconino. He's trained me well, and I've found some new things.
You're right there, right behind him.
But
you've gone different. You've done a lot more detailed and thing section work and things. But he did show that those reptiles, those lizards, were actually moving in water, didn't he? They were moving sideways up the. He
has an amazing paper. It came out in Geology, the journal Geology in 1991. The title of the paper included Coconino and underwater in the title. And he took a lot of flack for that. There was a firestorm about the Coconino after that. But, he still thinks that that's the best explanation. Nobody has been able to show a better way that those tracks could form other than underwater. I mean, his experiments I think document that completely.
So I know some, conventional scientists or secular scientists, whatever you want to call them, they try to say, well, it was wet. These dunes were wet at the time. There was a little bit of water, maybe a little lake between the dunes.
The problem is when you have damp sand, the sand becomes cohesive. And when something walks across it, it doesn't leave a deep footprint or even a very big footprint. As you walk along the beach, you see, something very similar, right? If you walk in the dry sand, you don't leave much of a footprint at all. There's kind of a depression, but no detail. Right. You walk in the wet sand, your foot doesn't sink in very far. But if you walk in the underwater sand, you can actually get some detail in there. The thing is that the track disappears, quickly by the surf. So
unless it's buried quickly.
Yeah. So we don't understand completely how footprints are preserved. But both the secular community and the biblical community, we have some work to do. And I never claimed to know all the answers and how everything forms. And there's always projects that we can study and work on, but I still think the best explanation is underwater. And that's where the fruitful research is going to come, I think.
Yeah, that's great. Well, before we wrap up today, could you... The biggest problem I think people have with the Coconino, the creationists, the confusion has come about those angle crossbeds.
Yeah.
Can you just summarize that again really quickly?
Yeah. So
what's the best way if you're out there and you're looking at crossbeds or you hear about crossbeds and you hear about these angles?
Yeah.
What's the best way to really know this is dry area sand dune or a water sand dune?
First of all, you got to measure with either a Brunt compass or there's cell phone apps that you can measure crossbed angles with as well. And usually it's an optical illusion. When you look at the crossbed, you overguess the angle. I've done that so many times, and you put a device on there,
it's different,
and it's a lot lower than what you expect. But the angles in the Coconino are grouped very tightly compared to modern dunes, which are very widely spaced.
So you get a closer grouping of the angles, really.
That's right, and I think that in itself shows that the Coconino is not a desert deposit. There's other details, of course, like details of the sedimentology, details of the crossbeds and how the crossbeds are shaped. We haven't had time to get into everything today, but the angle of the crossbed. Average angle is not the main thing. It's the spread that you want to look at, the crossbed spread.
Mm-hmm. Well, I'm glad ICR taught you so well in the graduate school when you went to ICR's graduate school, and of course Loma Linda.
Steve Austin was an amazing professor. I want to give a shout out to him.
Yeah, that's good. Yeah, Steve Austin's done some great work for ICR for many, many, many years, and we still showcase some of that here in our Discovery Center Museum. And there's work on Mount St. Helens that he's done. To wrap it all up, can you give us like 2 takeaways that really people should know about the Coconino Sandstone? People might read something about it, or they might even study it in school themselves. What should they know as Christians about the Coconino Sandstone?
So when I first got into this project, I read over and over again critics saying that the Coconino Sandstone in itself proved the Bible wrong. The Coconino proved that there never was a global flood because this desert sand dune deposit was in the middle of all these things we thought were marine flood deposits. And they said there's people that have said, that this unit alone disproves the Bible. And, the research that I've done shows that, and others have done, I've not been the only one that has done Coconino research, but the research that we've done shows pretty conclusively that this was deposited underwater. We don't know exactly the mechanism of how it was made underwater. We still need to do some, maybe even some numerical modeling to try to understand that. We can't do it in a laboratory flume or anything like that. It's just too big. But I think that's one of the takeaways is that, not to give up. The research is sometimes hard and it takes a long time and not to give up. But, the Coconino, I think, does support an underwater origin. And the other takeaway is that we can have, I think, faith in God's Word.
Amen to that.
And, so many people get distracted by something that supposedly gets found in science or so forth, and then they never seek it out. And, their first response is to doubt God's Word about the age of the earth, or doubt God's Word about how long the days of creation were, or doubt God's Word about the flood. And that's their first response. Instead of, getting out there and looking at the rocks and studying the rocks, their first response is to doubt God's Word. And I say we need to do it the other way around. We need to start off with God's Word, and then as we go out into the field, we investigate carefully. We report data honestly. That's always important. We might not always have the answer right away, or the answer may not always be apparent to us. We need to admit there's problems, but that's how we find solutions to things.
Well, that's kind of the same thing with my research. It's taken me over a decade to compile all the rock data across all the continents, and it's a lot of work. Yeah. A lot of people don't want to do the work. Even the conventional geologists don't want to do the work. They just want to accept the story they were taught, and that's why they just look at big crossbeds. Oh, that must be a sand dune, dry air sand dune, and they don't look at the thin sections like you did and spend the time and the trouble and the money to actually look at all these things, look in detail and see that this doesn't fit what you see in a sand dune. I don't think many people even know what sand dunes look like, but you went and studied them. And so the comprehensive research that you've done, to me, is just compelling to show that the Coconino Sandstone and many of these sandstones across the American West that are all the same age, all deposited about the same time, all part of a single unit probably deposited in the flood, was all deposited underwater, just as flood geologists predicted and what we expect.
Yeah.
But even when you start doing this research, I thought, I know the Bible talks about a global flood, and I started plotting up data, and I tell my audience sometimes, I'm like, when I started plotting, I said, I sure hope the data shows a global flood. But boy, did it. It showed the same thing on every continent at the same time. And same thing with your research. This is really, really compelling to show that there really was a global flood. And as flood geologists, kindred flood geologists, who believe in a young earth, who believe the 6-day creation, literal 6 24-hour days, and there was a global flood, because the Bible teaches we see the evidence, but it takes a lot of work sometimes to bring that evidence out.
That's right.
But when you look at the real evidence, the real rocks themselves, we actually see that.
Yeah.
So I thank you for joining us today.
You're welcome.
John, you're a good friend of mine and a fellow PhD in geology and flood geologist. It's great to talk to another person that really understands rocks in a lot of rocks that I don't even understand. You really know the Coconino better than I ever have. And you're a sedimentologist and a paleontologist, I guess. Mm-hmm. Is that what you call yourself? Kind of one of the two?
Done work in both areas.
I was more of a structural geologist. Here, most of my research has been in stratigraphy, which is a little bit different. We're looking at, I'm correlating rocks across from place to place, whereas you're looking at individual layers in this research. So it's pretty fascinating. But thank you so much for coming out here.
You're welcome.
And, really talking about the Coconino and the research that, you started with ICR, but you've continued at Cedarville. And it's just amazing research showing the truth of God's Word. It really shows that, we have the best jobs in the world, I tell people. We get to show people the rocks, scream out the flood.
We get to go those places and see the rocks.
Get to see all this stuff. So thank you all for joining us today on this Creation Podcast Extra. We'll see you next time.